Hello, everyone. My name is Janine Donnelly. I'm the manager of webinars for IBM Systems Magazine, and on behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. We will be holding a Q&A session at the end of this webinar. You can ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources. And you'll find that on the left side of your screen. And you can download the deck from the platform without being disconnected from the webinar. Today's webinar, Avoid the Digital Vortex with a Self-Managing Mainframe, is sponsored by BMC Software. Our featured speakers today are Dave Hilby, Area Vice President of Product Management, and Paul Spicer, Lead Product Manager for BMC. With that, Dave, I'll turn the presentation over to you.
Thank you, Janine, and welcome everybody. Paul and I are excited to talk to you today about this thing called the digital vortex and the self-managing mainframe. I think what we really hope to get out of this presentation with you is an opportunity to open up eyes a little bit on looking at new ways to manage mainframe IT infrastructure, given a lot of changes that have occurred over the industry with technology and so forth. So what type of pressures are we getting that may drive this requirement for a change? I know when I started out in this business, I was an IMS systems programmer. I had a pretty narrow scope of things I needed to look at. But I think given the changes of the mainframe platform, given the introduction of the digital economy, where your applications are directly in the hands of your end consumers, making it maybe a little more challenging to predict workload peaks and manage workload, given the additional governance we see. I've talked with a number of mainframe shops, and I'm amazed at how much time they have to spend on auditing projects and successfully filling auditing projects. A number of shops I've talked to also, there's tremendous skills and staffing challenges happening in the mainframe space. I think we finally hit that point where a number of us that have been around for a while are moving on to enjoy a different phase of our life. Well, how do we find those skills to replace that knowledge? And I think all of these things come together to basically suggest that business as usual for managing a mainframe IT infrastructure really needs to change. We can't necessarily simply do it the way we've done in the past, nor might we want to do that, because anytime you need to change, there's opportunities to improve and go forward. So with that, when you look at the changing aspect of IT operations, and as we've talked with mainframe shops, again, there's this driven desire, driven interest in looking at how to approach managing mainframe IT infrastructure a little bit differently. And there are some common themes that come out of that discussion. Those themes center around concepts of, intelligent software, but not just intelligent software, but intelligent software with domain expertise. And Paul's going to explain a little bit more what that means, but in a nutshell, how do you encapsulate that knowledge of those people leaving your shop? How do you encapsulate that knowledge in software so that you can have a very effective system to manage your IT infrastructure on the mainframe platform? Proactive early warning. I think we'd all agree that the best problem to have is one to avoid, right? And so the real goal here is, how do you create an infrastructure that allows you to capture potential problems before they ever occur? Sure, problems are still going to happen, and you want to quickly address those issues through fast mean time to recovery. But at the end of the day, if you can address issues before they even impact your business, that's the desired goal. But outages are not simply the only thing that happens in the mainframe environment to cause us to have a business outage or some sort of IT impact. But degradation analysis is also important. Sure, I may not have an outage, but if my system reaches a degradation point such that I fundamentally can't process the workload, then that needs to be addressed. And you want to address that in a proactive nature. You want to be aware of that before you hit that point so you can avoid it altogether. And then finally, if you have these concepts of intelligent software with built-in domain expertise, you're getting early warnings about potential problems, you're addressing degradation issues ahead of the curve, so to speak. Ultimately, you want to tie this into what I like to call trusted automation. Automation that you have a lot of trust in, that it can address these issues for you ahead of time. And in many instances, we think about automation as, hey, let me go change a system parameter, or let me go run a job or utility or something like that. You know, automation can simply be, let me send an email to somebody, let me open up a help desk ticket automatically, and let me put in that help desk ticket, hey, I saw these issues, here's what I think's going on, and here's potential remediation actions to take. So automation doesn't necessarily mean, you know, automatic under the covers going out and change your parameters with your system. Ultimately, you know, when you look at an infrastructure, when you look at self-managing mainframes, you want to get to that point, but it can be a path to get there, and before you have full trust in that automation. So again, as you look at the changes that have happened in the mainframe space, as you think about the things I mentioned on the previous slide, these are the key functional areas that need to be taken into account as you strive for more automation and more aspects of the mainframe managing itself. And it's, you know, a number of folks in the industry that are talking about that. Here's a very, very interesting comment from Gartner. And, you know, Gartner's comment here is basically saying that in the not too distant future, if the concepts of artificial intelligence and machine learning, which are technologies that can help us get to the path of a self-managing mainframe, if you don't take those technologies into account, the ability for your IT environment to remain viable, both operationally and economically, could be at risk. And it's very, very important then, I think, that these areas be looked at in terms of trying to bring some more self-management and automation, intelligent automation to your mainframe platform. Let's talk a little bit about some of the key concepts just to kind of level set. I'm always intrigued by the concept of machine learning, because at the end of the day, what machine learning promises for us is the ability to address issues, the ability to analyze issues, the ability to take corrective actions on things that the technology was not specifically programmed to do. So it can learn, it can understand your environment, it can relate the data in terms of understanding what is occurring at the moment, and from that it can reach a determination of what needs to get done. And again, Paul's going to talk a little bit about the idea of machine learning versus just you know, kind of hard-coded scripting type of technology. And finally, the other thing that's really important is this concept of intelligent alarms. And really what I layer in here is this whole concept of anomaly detection. It's very, very vital so that you don't get false positives when things occur in your environments. Anomaly detection becomes very, very important, and it's anomaly detection from a known baseline. And so what becomes really important is establishing a baseline and the ability to alarm intelligently when anomalies occur from that baseline. And again, Paul is going to go into this a little bit, but anomaly detection, the concepts of intelligent alarms, become very, very, very vital in this process of striving towards a self-managing mainframe. Let me talk a little bit about, just more formally, the real answers to a self-managing mainframe. As I talked earlier, there's this concept of this vortex, right, where volume of data is increasing. And we have studies that show this from our own work, that the growth of data on the mainframe platform is still happening at a pretty substantial rate. And then the velocity of work. We also have studies that clearly show transaction rates are increasing. They're going up. And the volatility, the unpredictable nature of the workload is also increasing. And this is that digital vortex I talk about in terms of the pressures and things you have to deal with. Well, when you look around at other industries as they've looked at similar problems, whether it be transportation, healthcare, financial institutions, they've really been successful adopting the concepts of artificial intelligence and in addressing these types of issues. And at the end of the day, that really is the answer here. We've reached a point where the technology on the mainframe is intelligent enough and fast enough for us to effectively use these concepts in driving towards that self-managing mainframe. The concepts of artificial intelligence. I talked a little bit about machine learning and intelligent automation, domain expertise. Hey, there are uniquenesses to the mainframe platform. And how do you take that domain expertise? How do you take that knowledge out of those people's heads, so to speak, so to speak, and put that and embody that in the software itself? And finally, how do you get value quickly, right? How does technology learn your environment quickly and bring you environment immediately and not necessarily require you to go through a ton of configuration and implementation decisions and lengthy time in learning your environment. So that's what I mean by out-of-the-box value. You need to have a solution as you look at potentially striving your own automation towards more self-managing, right? It's got to be easy to set up and easy to run. Let me talk a little bit now about just a little bit more about some of the components of a self-managing mainframe. At the end of the day, while if you're really, really successful with self-managing, then in theory, you really shouldn't have to see a lot visually. But data visualization becomes important because you're not going to catch every situation that may crop up. Some things are going to make it through the system and cause problems. But probably more importantly, you need to understand as your automation, as your self-managing mainframe is working, what has it done? What has it done for you? So it's very important to have a data visualization component that helps you truly understand what is the underlying self-managing technology doing. And probably most important thing is an audit trail, right? Why did this happen? Or more importantly, maybe there's some level of simulation mode you're in and you want to understand what would have happened. I talked a little bit about intelligent alarms in terms of the ability to look at anomalies and identify anomalies that are truly anomalies based on your baseline. And when I say baseline, I mean the baseline appropriate for that moment in time. There could be multiple baselines in your environment, and most likely there will be. Predictive analytics becomes very important here because at the end of the day, if there's an anomaly, I think what you really, really want to know ultimately is that anomaly going to cause a problem for me? Is it going to degrade my state? Is it going to cause an outage? Might it cause me to miss an SLA? So it becomes very, very important then when you look at a self-managing mainframe infrastructure that you have the ability to take certain metrics and predict into the future on whether or not I'm actually going to experience a problem here. Because frankly, if you're not going to experience a problem, then it really becomes something that you may not need to address. Ultimately, also, if you predict there's going to be a problem, you want to understand what is causing that problem. And that gets tricky, right? Because you want to kind of filter out the symptoms, and you really want to get ultimately to the root cause aspect of it. And so that becomes vitally important as best you can that you use standard AI techniques such as the embedded domain expertise, correlation information to try to understand what is actually the root cause of this problem so I can address. And ultimately, if you can get to that root cause, you want to prescribe remediation. Basically, what actions do I need to take? And again, it may go back to what I talked about earlier. It may simply be, hey, open up a help desk ticket. Or it may be something along the lines of I can go adjust some system parameters. Maybe I've got a situation where I'm consuming too many MSUs on a test LPAR. Well, it may be safe to go ahead and do a soft cap on that LPAR to address that issue. But you probably don't want to do that on production type LPAR. So what is that remediation? And then finally tie it into the automation. What becomes very important here, I think, though, is these boxes represent real-time automated management of the mainframe platform. This is addressing issues as they come up, addressing issues, frankly, before they become problems on the mainframe platform. But the mainframe really is normally a piece of a larger enterprise application. So when you look at a self-managing mainframe, what becomes vitally important is those key metrics need to be pushed to whatever broader enterprise analytics engine that your organization may be using to really step back and look at the broader enterprise picture. And that becomes important that the mainframe, the key metrics associated with the mainframe, participate in that broader enterprise view of the application, and be able to see the relationship between things happening on the mainframe and maybe things happening off other platforms. So there's really two key components here. One is understanding the enterprise, understanding the mainframe and the broader enterprise picture, and then real-time management of the mainframe platform instantaneously on the mainframe, addressing issues before they cause a problem for you. So I've talked about these concepts of the self-managing mainframe. Maybe to make it a little more real, let me share with you just a few ideas of the types of things when you look at a self-managing mainframe, the types of things you might want to look at in your own environment. And some of you may be looking at and doing some of this now with your own automation tools or packages or homegrown tools in your environment. But the types of things I think you can look at is, more quickly identifying deployment issues around application deployments in terms of driving automation to help application deployment, and let's even say potentially intelligent automation associated with deploying database changes associated with those application changes. Lots of times you don't think about it that way, and I'm going to talk a little bit more about that later on. This concept of seeing around the corner, which is really what I've been talking about here, right, is how can you look around the corner and see what issue might be coming up, and how can you address that issue before it ever impacts your environment. So looking at things like multiple KPIs and associating those KPIs to better understand that I may be heading towards a degraded state in terms of performance and so forth, or maybe even a system outage, and being able to avoid that. Looking at intelligent automation and the self-managing mainframe to help you understand, am I spending my money on the mainframe, whether it be software-oriented or whether it be hardware-oriented, in a real-time way, am I spending my money wisely here? Are there peaks and valleys that I can better take advantage of to optimize my spend on the mainframe? Are there best practices that your self-managing component can recognize and offer to you from that perspective? And of course, near and dear to all of our hearts really is around the idea of security and security threats, and we're always in the mode here of wanting to address security threats in a more thorough way and really avoiding the outages and the problems caused with security threats. So I think that when you look at a self-managing mainframe, these are the types of things we can look at. And many times we only talk about it in terms of performance, but it's even beyond performance and performance analytics where we can really strive for a self-managing mainframe. So hopefully I've given you a little bit of a view of the motivation behind wanting to strive towards a self-managing mainframe, and a little bit of a view of some of what can be in terms of the possibilities. I'd like to turn it over to Paul now. Paul, I think, is going to really take us down to the next level to understand, some of the technology and concepts and value points. So, Paul, I will turn it over to you.
Great. Thanks, Dave. Okay, so as you said, we're going to get down to a bit more level of detail. So when you're looking for tools to enable the mainframe to be self-managing, you need to consider a few key areas. Having loads of data is nothing without knowing what it is and what to do with it. And you need something that works out of the box without having to bring your own data science expertise to make it all work by yourself. And then having intelligence, domain expertise, and the right algorithms built into the product, it really makes all the difference in terms of making it easy to use and being effective. So what I wanted to do is kind of look at each of these in a bit more detail and sort of drill down into some of these attributes. So let's start here. So how many times have you bought something that you had to assemble yourself? And you get halfway through it, and then you start to think, you wish you hadn't done that in the first place. All you're really looking for is that finished working product. You've got better things to do than do all the assembly yourself. And really, it's exactly the same with software. It's very easy to buy something that's essentially a toolbox. You can do lots of things with it, but you've got to write all the rules and script yourself to make it work like you need it to work. And then, of course, when you've done all of that, you've got to maintain all those scripts and rules, forever after. And to be honest, this all requires a lot of time and skill. And we're seeing with the increasing complexity and unpredictability, that's creeping in. Most customers just simply can't afford to manage, the rules and scripts themselves. So, most customers I talk to, and I've talked to quite a few over the last year or so on these topics, but much rather have products include all that intelligence built in, so it's right out of the box, and they don't have to manage it and take care of it themselves. So the next area is really about the data sources, and with machine learning, data is really the king. Machine learning is using data to make its decisions. But to do that, the algorithms must have access to the correct data, and those data sources need to be both deep and broad to make sure the right data is there to allow the algorithms to identify problems and ultimately get down to pinpointing the root cause. All aspects of the environment must be represented. The operating system itself, things like the subsystems such as KICS, DB2, IMS, MQ, and of course the network as well. The data should really come from different sources. SMF is a great source of data, but I'm sure everyone's got monitoring products. Perhaps you've got MainView, has a ton of data built into it. Systems logs, console logs. The number of data sources is almost limitless. So with all of the right data, models can be properly trained, ensuring that they perform optimally. So problems can be accurately predicted in sufficient time to take effective action. There's not much point in predicting a problem, just as it's about to happen, and if you can't do anything, there's no predictive capability in that. And also, getting down to the root cause aspect, or the problem determination piece. If you can identify the root cause, the automation of determining the root cause, it also lets you better take automated remediation. And the key point here really is, if you don't know what the root cause really is, if you're trying to automate a fix, it's a guess at best in terms of how you're going to fix the problem. So, of course, anyone can create a huge data lake, and there's plenty of those out there. But it really comes down to what you can or can't do with the data in it that matters. And machine learning on its own certainly isn't magic. You need to apply data science to the data to identify correlations that are going to help identify anomalies. And then these are anomalies that, if left unchecked, are going to lead to real IT problems that ultimately are going to impact your business. And if your data scientists don't fully understand the mainframe and your data, you can end up with some very believable but not particularly useful correlations. And I like this example here, where we see there's a close correlation between the number of bedsheet deaths and the amount of cheese consumed per capita. But of course, is that going to help solve IT problems? No, of course it's not. you need the domain expertise, to apply that common sense that needs to be layered in, with all that data science, to make sure that you're only actually identifying correlations that matter. And to do that, as I say, it means you've got to have that domain expertise to figure that out and validate all the correlations that it's seeing. So, bringing the data scientist, and domain expertise together, can be a pretty expensive and challenging thing to do. And, oftentimes it might not actually be possible. And this is why you need products that already have this done, all this work done for you. So basically we're talking about products including domain expertise, or that common sense baked in that's relevant to your data, so that you don't need to spend the time with the data scientists and doing all of that for yourself and spending all that time and money to do that. So typically today, when we're doing monitoring, we're mostly looking at individual metrics to determine if there's a problem with the system. Maybe you're looking at things like CPU usage, or queue depth, or database contention. I'm sure everyone is already looking at many metrics, hoping to identify problems before they cause real system outage. Maybe you're just looking at your monitors to see what's going on, but hopefully you've set up thresholds to warn you when problems are occurring, so you don't need to spend all day actually looking at those monitor screens. Some of you may be using products like MainView, which for years has provided the ability to dynamically set thresholds based on normal activity. The idea being there that you can identify problems much sooner than you might with static thresholds alone. And all of the steps, as I just talked about, kind of represent a progression that we've seen in many shops today. But systems are getting more complex, and today you really need to be looking at multiple metrics and their correlation, so that you can identify anomalies and predict problems before they actually impact the systems. And multivariate statistics, as it says here, is a subdivision of statistics encompassing simultaneous observation and analysis of more than one outcome. And it concerns the understanding of different aims and backgrounds of the different forms of multivariate analysis and how they relate to each other. So what all that really means is, even if you've identified individual thresholds on all the variables that you might be using with multivariate analysis, it's possible to identify problems occurring before any of those individual metrics turn red. And that's because with multivariate analysis, it can detect that when several of these correlated individual metrics are shifting just perhaps even slightly, it's seeing an anomaly that's going to ultimately lead to a system problem. And conversely, if you're monitoring those same metrics and one of them turns red, multivariate analysis, because it's looking at the correlation of all the different metrics, has the intelligence to realize that just this one metric being out of line isn't going to impact your system. So the bottom line on this is the ability to watch different metrics from many different data sources is very powerful, and it helps you identify problems sooner and leads to better problem prediction. So, between Dave and I, we've talked quite a bit about machine learning. So I wanted to spend some time now taking a look at how machine learning is different to the rules that you probably have in place, whether that's in your monitors or your automation products. And you're going to see there's some pretty substantial differences here. So in this sense, when I'm talking about rules, I'm meaning, like both, thresholds that you've defined to help identify a problem, but also any automation that you might have written, such as rules or execs, that are actually there to help address a problem. And maybe that you're doing things today, like simply opening a ticket or cancelling a job, those kinds of things. So that's the kind of thing we're talking about with rules. So first of all, with rules, they're typically put in place after a problem has happened, and they're put there to stop it happening again, or at the very least to notify someone that the problem is starting to happen again. And obviously that's good because you're preventing it from happening again, but you had to sit through that problem the first time. It'd be better if you didn't ever have to deal with it in the first place. Also with fixed rules, if the situation changes just slightly, it's quite possible the rules you have in place might not actually catch it the next time, so you're kind of back to square one. I often talk to customers that have created many rules based on things that may end up just being one-time occurrences, and you're defining all these rules. You've got to manage them. You've got to look after them. You've got to be driving up your data, your monitoring overhead, data overload. I mean, there's a lot of issues with having lots of those defined. So, even with all of this successfully in place, the biggest issue here is that quite often the root cause of the problem is still not known, and the resolution to these things is simply to go tell somebody, hey, you need to go look at this problem and figure out what the root cause is so that you can take the right kind of action. So machine learning is all about unearthing hidden patterns from data. It's allowing you to monitor systems in a more efficient way. It leverages domain expertise that's built in up front, and intelligent models that self-assess and allow automatic retraining to find new normals, basically learning as they go. So you no longer need to wait for problems to occur and then write the rules just in case they happen again. Root cause can be identified, and automatic remediation can be taken. So in order for all the things that I've just been talking about to work, there's a lot that has to go on behind the scenes. So when you look at this chart here, the top row of boxes is the things that a vendor should be doing as part of product development. These are all steps necessary to make sure the models are correct and that the proper domain expertise is built in and everything works as expected. So first of all, we need to go back to the data. Machine learning is all about having the right data in place. Without access to good data, going back over some amount of time, you just aren't going to get good results. And the data should come from a variety of sources, and not just vendor internal data, and it's got to represent real-world customer situations. That data is evaluated by data scientists and domain experts to make sure that the right metrics are available, and then the product teams go about building products using the appropriate models to work with the data that's available. And then the next part is absolutely the key part. The models have to be trained using that data. And the way this is done is using historical data to sort of predict the past. So what this means is that half of the data available is used for training the model, and then the remainder of the historical data is used to verify that the models can predict what happens next. This sort of training evaluation cycle continues until you're getting the proper results out of it, and only then is the product ready to be deployed. And then once the product is installed in a customer environment, new data is available that's specific to that customer environment, and the model will continue to learn and do scoring, determine baselines, take feedback, and continually reevaluate and learn that environment so that it's providing the best results for you. So let's look a bit at creating and using baseline models. So baselines are the basis for everything when it comes to detecting anomalies and making predictions. So using the available historical data and continuous learning that I talked about on the previous slide, the product needs to gain an understanding of what is normal for a given point in time. And so this needs to include things like normal daily fluctuations, things like the mid-morning peaks, quieter times at lunch. But more than that, it also has to understand special time series data. From some examples might be understanding it's a weekend or perhaps a long holiday weekend, it's the end of the month or the end of the quarter where there's different processing models, and special things perhaps like Black Friday, and then also different combinations of those events. And then using that information, high and low normal range can be established. And you can see the plot on these charts that shows the normal high and the normal low. And then when the current metrics are in this range, for this time all is good, you can see in the two examples here, we have two different metrics going out of range at the same time, which in this case is a sure sign of a problem. They're both way out of normal and clearly an anomaly that action must be taken on. So before I turn this back over to Dave, I just wanted to walk through a scenario, where the things that I've talked about over the last few slides comes into effect. So with traditional eyes-on-glass monitoring, or even static thresholds that a lot of people are using today, currently we rely on things to become very wrong, and outages are learned very much one at a time. So in this situation here, a real-life crisis, which is actually based on a true event, something wasn't very wrong in the beginning. This problem unfolded after many hours. System outages, as I'm sure we all know, are often the compounded effect of multiple unnoticed failures in the systems. And waiting for something sort of really big to show up is usually too little, too late, and can lead to expensive and really avoidable outages. So in this situation here, we have an application that's rebound at the weekend, but the access path changes and a table space scan is used instead of an index. So now the application's using a lot of extra get pages, but there's no extra I/O because the pages are loaded in the buffer pool. But extra CPU is being used, and due to this is a high priority workload, all other applications start to be affected. And then peak time production workload arrives, but there's no CPU left on the system, so the entire system starts to stall. More threads are allocated to try and keep up, but then all they do is cause more contention, CPU usage, and storage. So eventually the system runs out of storage, and you have a complete outage, obviously costing potentially millions of dollars. Quite often what happens in this situation, war rooms are set up, everyone's brought into the room together and trying to figure out the root cause of the problem. So if we look at that same scenario, tomorrow, so now we've got machine learning and intelligent automation in place. The situation I talked about can be detected and fixed long before it starts to really impact the system. So just as before, applications rebound at the weekend, access path change, table space scanning used instead of index. The application's using those extra pages, but there's no extra I/O because the pages are loaded in buffer pool. So far, exactly the same as it started before. The difference now is that the subtle change in behavior is completely detectable using machine learning and the built-in domain expertise. So the profile of the application, buffer pool usage, CPU usage, and storage has already been baselined. We've been in this environment for a while, and the correlations between these different variables are understood. So an abnormality for this customer at this time of day is easily identified. There's no sort of one-size-fits-all, high watermark kind of monitoring going on here. So in this particular scenario, the application is corrected hours in advance of when that actual failure would have occurred without this kind of technology in place. So obviously resulting in huge savings both in time and effort and customer satisfaction. So Dave, I will turn it back over to you, and you can talk about DevOps.
Thank you, Paul. Hopefully, for the listeners, Paul was able to kind of share some of the key technology components of a self-managing mainframe, some of the basic technology that's been used for years and years on other platforms, other industries, and so forth. Those apply here also. But I want to talk to you, I want to take just a moment to talk to you about a use case that you may not think of. When you think about a self-managing mainframe, when you think about AI, many times your thoughts naturally trend towards thinking about, let me avoid a performance problem, or let me avoid an outage, which are really important things to do. But the concepts of self-managing can extend beyond that. And the example I'd like to show you here is around DevOps, right? And what we see is a number of situations where mainframe shops have invested, let me take that back, actually the IT enterprise has invested heavily into DevOps and DevOps automation. Why? Because they want to bring continuity, they want to bring clarity and communication, They want to bring some discipline to their development software application rollout process. They want to bring automation to that, and they want to reduce errors. And probably most importantly, they want to do it because they want to increase their ability to react quickly, whether it be in a competitive situation, net, they want to be more agile and reacting quickly to market needs, technical needs in this highly competitive environment we live in today. But what we've discovered as we've talked to a number of folks in this situation is that while the DevOps tools allow you to roll your application release changes out fairly quickly, there is not necessarily an ability to roll and stage your database changes. If you have application changes that require changes to your database, in many instances, there really isn't the automation that allows you to do that in a very disciplined, correct fashion. And the result of this is you get this velocity gap, right, where the company really wants to roll these changes out fairly quickly, but time and tested procedures and process may not necessarily let the corresponding database changes. So while they want to be more agile, there's a leg of their process that doesn't necessarily support that agile goal. And this is kind of just the idea of behind this. I'm sure many of you have been involved in this, so you probably understand this. But on the left side of the graph, a slide here, you kind of have the application developer, the application area that again wants to be agile. They want to move quickly. They want to react to market needs and technical changes. But then you've got the other part of the organization that is focused on process, procedures, protecting the production environment, even protecting the various test environments in terms of just making sure or minimizing the opportunity that something may get into these other environments that really cause a business impact, whether it be production or high-end test environments. And so you really, to some extent, you really have these two organizations that are somewhat, I'll use the term lightly, kind of butting heads a little bit, right? And their goals are different, but they're all striving to meet the goals that their business, that their corporation gives to them in terms of what they can do. But if you look at the idea of a self-managing mainframe and the concepts of automated intelligence and the concepts of machine learning, the process can apply here also. And this is an example where you may have an application change triggered through a DevOps tool. That application change through the self-managing mainframe technology can be analyzed. That application change can be analyzed, and the analysis of that change basically defines, is there a corresponding database change that needs to occur? And again, let me suggest there's all sorts of checks and balances you'd want to automate into the system. Obviously, you don't want something just simply rolling out to production without any intelligent eyes looking at something. But you can automate this process through machine learning and AI to close that velocity gap, to allow the whole organization to be agile as they want to be. But at the same time, you can layer in rules that automatically get evaluated to make sure that the change that is moving forward is acceptable to the organization from a compliance, from a standards point of view, that it's acceptable to the organization from a performance point of view and best practices point of view. And you can even say, look, I still want to have a manual step at the end. I want a DBA to approve this. Maybe the DBA gets a report and it says, here's this change, here's what it involves, and check, it met all this criteria, and the DBA simply approves it and moves it forward. So again, the key here, I think, to understand is broaden your perspective on how a self-managing mainframe and all the technology that goes with it can be applied in this environment. It's not simply around performance availability. It can be applied to other business, other technical processes. Hopefully that kind of opens your eyes a little bit. And some of you may have done some things on your own already in terms of some homegrown type of automation here that begins this process a little bit, and I applaud you for that. Well, finally, I think we're getting towards the end here. Nothing would be complete without me having a little self-indulgence here. BMC last week at a key BMC exchange conference in New York City, we announced our new line of business in this space of a self-managing mainframe. We call it Automated Mainframe Intelligence, or AMI. You'll hear the term AMI quite a bit, and so what really AMI addresses is both of these key fundamental areas that we talked about, which is how do I make sure the mainframe is part of the bigger enterprise picture? Probably more importantly, how do I make sure the mainframe and the value of the mainframe is part of this broader enterprise picture? And so Amy is introducing and bringing to the table these concepts of enterprise connectors and the ability to get that really, really key ZOS data into your broader enterprise analytics engine. And then secondly, Amy also offers the autonomous self-management on the ZOS platform itself in terms of driving through the predictive analytics, the root cause analysis, and addressing issues in a very, very quick, immediate fashion on the ZOS platform itself to, again, ultimately avoid the issues that may have caused degradation or may have actually caused an outage. So we're very excited to make this announcement, and you'll see more and more about Amy as BMC continues to roll this out. So I hope what we've done is helped share with you the concepts of a self-managing mainframe. It's very clear that the changes in the mainframe environment, the impacts of all the things I talked about earlier, whether it be the digital economy, the staffing challenges, additional compliance, audit requirements, other business pressures, right? You have challenges with a number of highly skilled people maybe retiring now. And this just kind of basically says and begs the question, I can't continue managing my mainframe IT infrastructure the same way I've always been doing it. I've got to be more efficient and smarter about that as we go forward. And I hope that what Paul and I have done here is kind of talk to you about some of the key elements of doing that and things for consideration, and also share with you a little bit about what we are doing here at BMC as we strive towards this self-managing mainframe initiative. So with that, I am done, and I believe that, Janine, we're ready for questions. So if there are questions, I think we're ready to take them now.
Great. Paul, do you want to kick off that Q&A session?
Sure, we can do that. So,
well, I see we've got one that came in here. Let me answer this one real quick. There is a question that came in that said, I'll just read it. It says, so intelligent alarms are based on the results of predictive analysis. Is that correct? And yes, I mean that's a very good observation of what I talked about earlier in the session, in that intelligent alarms implies the ability to understand where is this going to go, right? So I have to have that predictive ability to understand, is this going to impact my system? You know, we get flooded with information in terms of metrics and things happening on any platform, but especially the mainframe platform, right? And so the real goal here is, can you build intelligence which includes predictive analytics capability? Can you build intelligence into the things that either you're notified by or into the things that further down the path here, root cause analysis is going to look at, and also automation is going to look at? So you're absolutely correct. Intelligent alarms embrace the concepts and the practices of predictive analytics. Very, very good question. I see another one here. I'll go ahead and take it, Paul. We are already passing data to Splunk for analytics. How is the structure you described different? Well, number one, I applaud you for that. I applaud you for beginning to jump into the analytics area and beginning to understand how analytics can be used to optimize your environment, whether it be from a availability, performance, or cost perspective. So very, very good from that perspective. I think the thing that's important to understand is that from our perspective, there's really a strong need to have the autonomous real-time management active on the mainframe on a 24/7 basis, right? That is, at the end of the day, that's the best way to take advantage of that embedded domain expertise, right? The ability, Paul talked about bed sheets and the relationship, the correlation with eating cheese, right? Well, you need that domain expertise active on the mainframe as it's looking at issues, potential issues on the mainframe. You need that domain expertise there to understand, have I got a cheese and bed sheet correlation here, or have I got a real correlation that's important to understand, as Paul said, this multivariate analysis, to understand the relationship between data components. And so that piece runs on the mainframe. That piece is vitally important to self-manage the mainframe on a 24/7 basis. And to your point, you're already extracting key data and bringing it to the Splunk platform, which is a key second half of the self-managing mainframe, to understand how does the mainframe fit into the rest of the enterprise application picture. So I would suggest that it's important to do both halves of that equation. So thank you for that question. Any other questions?
So we've got one here that says, how does this work with my existing main view monitors? Does it replace them? So the simple answer is it does work with main view monitors. It can, obviously there's a lot of metrics and data in main view monitors, so it doesn't replace them. It augments them. I think that's probably the simplest answer to that question.
Yeah, and I see another question here. Do you have AMI for other platforms? Great question, right? And yes, we really do. I mean, when you look at BMC as an enterprise company, we have analytics and self-managing aspects for all other platforms. I think what I'm talking about here today that's a little more unique is the domain expertise and the intelligent automation that is unique to the mainframe, right? When you look at the uniquenesses of the mainframe and try to say correlate, different key metrics across the mainframe, obviously those key metrics, whether it be specific to KICS or DB2, are really not going to translate to other platforms. So while the infrastructure covers other platforms, what's really key here is that uniqueness in the domain expertise, on the z/OS platform. I see another one here. Is this a repackage of the CoreLog assets with a partner acquisition? So just a little background, BMC announced our intent to acquire a SIM company, CoreLog, and bring them into the partnership, bring them into the BMC fold from a product point of view. And good question. Our intent there really is to exploit the capabilities in CoreLog technology to really enhance AMI and how AMI delivers value to the mainframe platform from a self-managing perspective. So it is a combination of exploiting some CoreLog technology and developing new technology that is on top of that, and aspects of it will be separate from that also.
Hey, Dave, this is Janine. It looks like we're going to have more questions than we can possibly get to, so it might be a good time to wrap up. I do want to let folks know that if we did not get to your question, someone will reach out to you via email to get you an answer. So I want to thank everyone for attending today's webinar, and a special thank you to Dave and Paul for sharing their expertise with us today. Watch for a follow-up email later this week, most likely tomorrow. It will contain a link to the recording of today's event, and it looked like we had a ton of interest in the topic, so I'm sure you'll want to have an opportunity to watch that recording and pass that link along to your colleagues. So with that, have a great day. That concludes our webinar.